Right. We're going to get started with 5.3. This is a long section. Today is a lot longer. If we don't finish it, we will finish it tomorrow. Okay. And the whole 5.3 should be finished up by the end of the day tomorrow. And then you won't have anything Wednesday because it's a break. And then Thursday we'll review and Friday we'll test on chapter 5. So be ready for that. Okay. Again, be ready for a chapter 5 test. It's probability. It's easy. You can do it. You can do it.
I don't think it can.
You can do it. All right. So the idea or the probability we assign for an event can change if we know that some other event has occurred. This idea is the key to many applications. So what is conditional probability? So let's go back to the Peirce-Sears example. And then here's the summary of our results. We did the probability of A, which is the probability of somebody being male. What did we say that was? Male was, what's your probability? Anybody, please.
90 over 178.
See, you already got it. Look, 90 over 178. We had the probability of B, or the probability of being pierced. What is that probability? 103 over 178. We also talked about the probability and A and B. So that was the probability of male and pierced. Okay, male and pierced. And if we look in the chart, male and pierced is 19 out of 178. And then we also did A or B, and we put in the union and the intersection, the N and the U. So the N and the U. Male or P or pierced. Make sure that you remember or can be male or pierced or both. And we got to take out for the both. Make sure you take out that overlap. So we got 174 out of 178. And that's all from last week's notes. So if you need to go back and check that out, that's fine. All right. So now let's turn our attention to some other interesting probability questions. So we're going to talk about the idea of conditional probability. If we know that a randomly selected student has pierced ears, what is the probability the student is male? There are a total of 103 students in the class with pierced ears. We can restrict our attention to this group since we are told that the chosen student has pierced ears. Because there are 19 males among the 103 students with pierced ears, the desired probability is. So again, look at this one more time. The probability that a student is male given that they are pierced. So what it says, there's only 103 people that are already pierced. So that's all we're looking at. Given that they're pierced, only the total number that are pierced. So remember I told you it's what you want over your total. So our total pierced is 103. But we wanted male that were pierced. So look back in your chart and tell me how many male are pierced. That's it. Which is approximately 18.4%. I don't necessarily need the percent, okay? All right, so what we're doing is we're given a condition. The condition was that we're only looking at pierced, okay? So that given is what we're looking at. So if we know that a randomly selected student is male, so we're given that they're male, we're only looking at males, what's the probability that the student has pierced ears? So now we're kind of reversing it. This time our attention is focused on the males in the class. Because 19 of the 90 males in the class have pierced ears, so here's what we're doing, the probability that they're pierced given or knowing that they are male. We're only looking at males, so what's our total males?
90.
And then how many of those are pierced?
19.
Yeah. Which is approximately 21.1%. These I guess it should say 2 questions, sorry. These 2 questions sound alike, but they're asking about 2 different things. So what we're doing is talking about what population, so we're checking a different population each time. Okay. Sorry. A probability like the probability that a randomly selected student is male given that the student has pierced ears is known as a conditional probability. Again, because we put a condition on it. The name comes from the fact that we were trying to find the probability that one event will happen under the condition that some other event is already known to have occurred. We often use the phrase given that to signal the condition. There even is a special notation to indicate a given probability or a conditional probability. In the example above, we would write probability is male. It's a big vertical line and I over exaggerated it so you guys could see it. That means given pierced ears. Where the vertical line means given that or under the condition that. Because we already defined the events A is male and B has pierced ears, we could write the conditional probability as the probability of A, because we were talking about that was male, and B was pierced. You need to know this. The probability that one event happens given that another event is already known to have happened is called a conditional probability. That's just a definition again. Suppose we know that event A has happened, then the probability that event B happens, given that event A has happened, is denoted. So B, right here, B given A, looks like this. B, vertical line for given, and then A. So let's look more closely at how conditional probabilities are calculated from the two-way table below. We see that the probability of male given pierced, and I've already went over this in the very beginning. Male given pierced is the number of male and pierced over the number of pierced. So this is what it looks like. If we have the probability of A given B, that's male and pierced, we already knew that. On the top, we're going to have the probability of A and B over just the probability of B. Okay, let me go back and show you something real fast. I'm going to come back to this page. From the beginning, we had the probability of A and B was 19. The probability of just B was 103. That's where those numbers are coming from. But we've already done it down here. We already know what we're doing. I'm just showing you how to read the chart. So in symbols, again, that's what I just did. The probability of A given B is the probability of A and B over the probability of B, which is 19 over 103. Now, again, let me show you how we get this just in mathematical terms. I'm going to go back up to the chart for a second so you guys can have room. So the probability of A and B, we said was 19 over 178. That was from the beginning. That's what I just re-showed you. Over the probability of B was 103 over 178. Remember that we don't divide fractions, we flip and multiply. So we would keep the top fraction, flip the second fraction and multiply. And remember, when it's the same on the top and the bottom, you can mark it out or reduce it. That's basic algebra stuff. And that's how we get our 19 over 103. But we don't have to do that. When we have that chart, we don't have to do all that crazy work, okay? All right, so again, just showing you how we get it. This observation leads to a general formula for computing a conditional probability. To find the conditional probability, P of A given B, we're going to use the formula that I just showed you. We're just going to write it again. A given B is the probability of A and B over the probability of B. So and on top, and then your second, whatever your second thing is what you want on the bottom. So then if we flip it around, the conditional probability is B given A. What is our formula? What is our formula? Okay. You can do B and A. So some people think of it like that, but it's always going to be over the given. Okay. But this top part, A and B and A are the same exact thing. Okay. So it doesn't matter how you write the top. Just remember that the bottom is always the second one or what you're given. All right, flip it over when you're ready. So going back to that, who reads the paper? In one previous example, we classified the residents of a large apartment complex based on events. A reads USA Today and B reads the New York Times. We did this really quickly at the end. The completed Venn diagram looked like this. So just to remind you what it looked like. Had the Venn diagram. We had event A and B. The overlap was 0.05. Just A was 0.35. Just B was 0.20. And nobody reading either paper was 0.40. Then it said, what's the probability that a randomly selected resident who reads USA Today, that was event A, also reads the New York Times? So which one are we given? Which one do we know?
Who reads USA Today?
It says they read USA Today. We want to know which ones of those read the New York Times. So this is the probability of B given A, because they tell us they do read, they give us that they do read the USA Today. So my formula for that, the probability of A and B over the probability of what? A. It's always the second one. Always the second one. All right. Where do we find A and B in the chart or in the Venn diagram? The middle part, 0.05. Very good. I should get do it, Mackenzie. Probability of A. Be careful about this one. We want the entire A. We want the 35 and the 05. Okay, so that's perfect. 0.4. When we put this in our calculator, I'm not going to make you do it, but you get 0.125. Now, how do I interpret this? How do I interpret? Because you're going to have to interpret, so remember that. There is a 12.5% chance that a randomly selected resident who reads USA Today also reads the New York Times. So we knew these people read the USA Today, but then we wanted to find out if they also read New York Times. And again, if you guys look, it's this exact sentence right here. It's the same exact sentence with the percentage put in. The probability is blah, 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 that a randomly selected resident who reads USA Today also reads the New York Times. So it's right there for you, okay? All right, check your understanding. Students at the University of New Harmony received 10,000 course grades last semester. The 2A table below breaks down the grades by which school of the university taught the course. The schools are liberal arts, engineering and physical sciences, and health and human services. College grades tend to be lower in engineering and the physical sciences, EPS, than in liberal arts and social studies, which includes health and human services. Choosing University of New Harmony course grade at random. Consider the two events. E, the grade comes from an EPS course, and L, the grade is lower than a B. Find the probability of L. Interpret this probability in context. So I told you we were going to have to interpret, so there it showed up. And then the second one is find probability E given L and probability of L given E. Which of these conditional probabilities tells you whether the college EPS students tend to, earn, sorry y'all, lower grades than students in liberal arts and social sciences, and explain. So let's work on the first one. I'm going to try to keep everything up here. Remember, when you're trying to find the probability, it's what we want over the total. We want to know the probability of grades lower than a B. Doesn't matter what course they're in. No, we're not given anything. So we're talking about out of all the grades, which ones are lower than a B. So we want lower than a B out of the total grades. So how many grades are lower than a B? What do I have to do to find that? Yeah, add all these up. I'm gonna go ahead and tell you the total is 3656. And then what do I need to do? What's the total number of grades we had? They already told us. 10,000. This gives us 0.3656. Interpret that. Don't, guys, please, on your test, make sure you answer all parts of the question, okay? So it'll ask you the probability, and you guys have been giving me a probability, but then you don't interpret it. So make sure you interpret it. So what do we do?
The probability that a student will get a grade lower than a B is 36%.
That is absolutely acceptable. Just to keep it consistent, there's a 36.56% chance. This is the one thing that you have to say, that a randomly selected, make sure that's in there. Grade is lower than a B. All right. Number 2, we have to find 2 conditional probabilities, and then we have to answer a question. So there's 3 parts to this question. The first one, probability E given L. What's the actual formula for that? The probability of what?
E and L over probability of L.
Okay. Look for E and L. E and L. What is E and L? What was E? What was just E in general? What did it describe? EPS, right? So that's that middle row, the engineering and physical sciences. but we're given L. What was L? Lower than a B. So how many are in the engineering and lower than a B? 800, perfect. Okay, engineering and lower than a B. If you need to write that down, write it down. We already found P of L. What was it? How many total?
10,000.
No.
36.
Yeah, 36.
Yeah.
Not even the decimal. We just want the probability that we're going to have lower than a B. Again, here's where it's kind of throwing you guys off. So this one would be 800 over 10,000. This one would be 3656 over 10,000, but we don't need the 10,000. Does that make sense? Because it cancels out in the end. So basically all we want is the numbers. So then we put it in our calculator. We get 0.219. You're going to do the same thing on the next one, except we're doing L given E. So the top number is going to be exactly the same, E and L, but the bottom is going to change to that E. That's what's going to make it a different number, okay? We already know E and L is 800. L and E is 800. It doesn't matter what order you put those in. But what's the probability of E, engineering? What do I have to do to be able to find that number? Yeah, add that row up. So I got to go up here and I got to add these up, and I'm going to go ahead and tell you it gives you 1,600. Okay, 1,600. So I'm going to drop back down here, which gives me a percentage of 0.5 or 50%. So there's the first part, find P of E given L and find P of L given E. Which of these conditional probabilities tells you whether the college's EPS students tend to earn lower grades than students in liberal arts and social sciences, and explain? Which one? Which one, which one can we use to compare to the liberal arts? There's only one we can do.
Is it the first one?
Not quite. So the first one says, given that they're failing, they're in an EPS course. The second one says, given that they're in an EPS course and they're failing. Go back to number one. What was number one? What was number one?
They're not liberal arts and they're failing.
Probability, not that they're failing, but I say failing, but that makes you think about it. So that's the probability that they're failing. So not in liberal arts. L has nothing to do with liberal arts, right? It's just the grades. So 36% of people are failing. What does this tell you? How many are? So out of the total failures, 3656, 50% of them are out of what course? The EPS course. So that's what you got to be able to define. So since 50% is greater than 36.56%. We can conclude that grades are lower in EPS courses. Okay, so use basically all the information that they give you. And you guys can see that out of their totals as well. You don't have to really go into it that much. Okay. All right, flip it. The general multiplication rule and tree diagrams. These are really easy. These are not hard at all. So suppose that A and B are two events that are resulting from the same chance process. We can find the probability P of A or B with the general addition rule. This is just going back to what we did the other day. The way we found it was we just added them up. Sorry, that should be a P. But remember, if they're not mutually exclusive, then we have to subtract out the overlap. So don't forget that. How do we find the probability that both events happen? If both events are happening, that's A and B. You do the probability of A times the probability of B given A. This is going to sound crazy, okay? Don't stress about it. This is kind of like a proof in geometry or whatever, just proofs. So if you've done proofs before, this is exactly what we're doing. If you don't understand that, all you have to do is memorize the formula. Okay, so if you don't understand where it comes from, not a huge deal. You just have to know the formula, okay? So what this actually gives you, this P of A times, what's the formula for this B given A? What did we just do? And I'm going to do A and B. I always do A and B. That's just me. If you do B and A, it's the same thing. Over the probability of A. What happens if you have the same thing on the top and the bottom? They cancel out. So that just leaves you with the probability of A and B. So the numerator, the probability of A and B, is the probability we want, because the probability of B and A is the same as A and B. We're going to multiply both sides of the above question by P of A, which is exactly what I just did. To get this, the probability of B and A is the probability of A times the probability of B given A. This is just the formula that you have to remember. This is how they derive it. Not a huge deal. This is called the general multiplication rule. The probability that events A and B both occur can be used founding the general multiplication rule. Just the definition again. So again, the formula that you need. The probability of A and B is the probability of A and B. And to find that, we do the probability of A times the probability of B given A. Where the probability of B given A is the conditional probability that event B occurs given that event A has already occurred. In other words, this rule says that for both of two events to occur, first one must occur, then and then given that the first event has occurred, the second must occur. This is just common sense expressed in the language of probability, as the following example illustrates. So don't stress too much about it, just be able to use the formula, okay? So using the general multiplication formula, the Pew Internet and American Life Project find that 93% of teenagers ages 12 to 17 use the internet, and that 55% of online teens have posted a profile on a social networking site. So find the probability that a randomly selected teen uses the internet and has posted a profile. Show your work. So what I didn't give you are the things that they, the actual probabilities. So I'm giving this to you now. I didn't do it because I didn't want anybody to go ahead of me. So the probability of being online was 0.93. The probability of having a profile given online was 0.55. So it says the Pew Internet and American Life Project found that 93% of teenagers use the internet. That's where that comes from. And that 55 have posted a profile on the networking site. So they're online, have posted a profile. Find the probability that a randomly selected teen uses the internet and has posted a profile. So what are we looking for? What are they asking for?
Probability of they have a profile given they're online.
Other way around. Uses internet and posted a profile, right? So online and profile. You need to be able to do this, okay? They're going to give you those percentages and you have to do this formula. So then, knowing what we did up here, here's your formula right at the top of the screen. This is your A, this is your B. I need to do the probability of A times the probability of B given A. So what was your probability of A or your probability online? 0.93. I'm going to change this to a multiplication symbol. What about probability of B given A, profile given online? They give them to you. It's nothing crazy. When we put those together or we multiply them, we get 5115. Find the probability, show your work, and then let's interpret this.
Ms. Jones, why didn't you do the fraction of the, like, I'm just so confused where this formula is coming from.
Okay, all of this up here showed where it came from. So we don't need any of that. What you need is this formula right here, which is the same thing as this formula right here. So all you need to memorize is the formula. That's it. It's not necessarily got to go with how you get there.
I thought the probability of like an event given another event, isn't that a fraction? Like, don't we need to put that 0.55 over something?
It is. That's how you got 0.93 and how you got 0.55. Those are your fractions. Yes, no, maybe. So what you're doing, these are not fractions anymore. You could do 93 over 100 and 55 over 100, whatever, and you're still dividing them. So let me see if I can throw this out real fast. I'm flying up the seat of my pants. We'll see what happens. All right. 93 over 100, 55 over 100. If we have the probability of B given A, okay, what was the formula for that? Right? Probability of A and B over the probability of A, right? Yes, no, maybe?
Yeah.
Okay, so then right here, our probability of A is 0.93 or 93 over 100. On top, A and B was like that 55 over 100. It's not going to be this because you don't have this formula. But then we have to flip and multiply. This formula that we have up here keeps you from having to do that flip and multiply because you don't have any fractions. Does that make sense? So we're just multiplying. Because we're not turning this into that big fraction like this. It's taken this part away. Rachel,
Yeah.
she don't, it's not there. I'll explain, we'll get back to it. We'll get back to it. Interpret this. What did I say you always have to have? And what are we randomly selecting? uses internet and posted profile, and I'm not making a very good sentence, but y'all get what I'm saying, on social network site. All right. I'm gonna do one more little paragraph and then we're gonna go out and come back in. So to finish this up. All right, the general multiplication rule. Is especially useful when a chance process involves a sequence of outcomes. Involves a sequence of outcomes. In such cases, we can use a tree diagram. Rachel, this may clear it up more, okay? All right. I'm gonna stop sharing and stop recording on this, and then we're gonna come back in, and we have not all of this that we're gonna do. We're gonna do a little bit with tree diagrams, and then we'll stop. All right, so stop share.